Dear students, today we will perform activity. Name of activity: gas leak detection using MQ2 gas sensor in Tinkercad. Okay, so we are going to perform this activity in Tinkercad simulation tool. Okay, so web-based tool. So devices used are breadboard, Arduino, Uno board, LCD display, gas sensor, buzzer, LED resistor. This is a topology. Okay, so first I will open the Tinkercad platform. I have already connected the devices. Coding also done. Okay, so just I will show you that. Okay, this is the what we say the connections, the topologies. Okay, the devices. Okay, this is a breadboard. This is the buzzer. Then this is the MQ2 gas sensor, and there we have LED resistors, and then we have LCD display, Arduino Uno board. Okay, this is the connections. How we give the connection is like a buzzer has two pins. Okay, one is plus pin. There I connected the pin number, digital pin 4. Okay, D4. The negative it is connected to ground through a resistor. Okay, then we have MQ2 gas sensor. It has 6 pins, 3 on the bottom, 3 on the top. 3 on the top are connected to positive pins, plus pins in the breadboard, and the 3 on the negative, 2 are connected to negative, 1 is the signal pin connected to A0 analog input pin. Okay, then we have two LEDs, one red, one green. So whenever the gas value goes above a particular limit, the threshold value, red LED will be glowing. That's why we have red LED, and we have two pins for that. Okay, one is connected to the red LED, one pin connected to digital pin 2, and the other one negative it is grounded through a resistor. For green also, whenever the value given by the gas sensor, the voltage given by gas sensor is appropriate, not above a particular level, means appropriate level means it will turn on green LED. For that we have two pins, one pin connected to digital number pin number 3 of Arduino, the second one connected to ground via resistor. Then we have an important one, it's called as LCD display device. Okay, so this has many pins. Okay, so many pins are connected. Okay, first thing, ground, VCC, then VO, V0, RS, like that. Okay, so what is ground? Grounded. VCC means given to plus 5 voltage. This is given to plus 5 voltage of the Arduino. Okay, V0, I already given the pin numbers here. V0 is actually it is given for contrast. Okay, so for the contrast, no, we have it as some display device. No, we need to adjust the contrast. So contrast, we are given this one. This is connected to negative. Okay, then we have RS, register select. Okay, what is a register select means? We have two registers inbuilt here. One is data register or instructions register. So data register will store only datas, whichever data you want to transfer between LCD and the device. Okay, instruction register will store the instructions, the commands like set cursor. What type of command you're using, instruction, that is stored in instruction register. Data register will store the data. So you want to select which one you are going to use, instruction or data register. For that we need RS. Okay, select the register. Okay, then we have, what is the other one pin is RW, any read or write. What type of thing, what type of operation you are going to do, whether you are going to write the data into the LCD or read the data from the RAM. Okay, so that's what written here. Okay, so here it's written there, read write tells the LCD whether we should read or write the data to and from RAM, random access memory. E means enable bit, tells the LCD when it should read the data, what time it should read the line. Okay, when the enable pin is enabled, no, that pin is enabled means then we can read and write. Okay, so this is enable. Then we say what is DB0, DB1, DB2, DB3, DB4, DB5, DB6, DB7. These are all like a 8-bit serial bus for transferring data. This is data bus. Okay, here I am taking 4 pins for data bus. Okay, DB4, 3, DB4, DB5, DB6, DB7. All these are connected to the digital pins, say 8, 9, 10, 11. Okay, LEDs, two LED pins are there. It's actually for giving the support for the LCD, for illumination, for, see here, light emitting diode. What they do is backlight support. Okay, so it will power the LCD. You know, the LCD device is not like your cathode ray tube. We need some power. We need to turn on the LED for giving the backlight. Okay, and to control the contrast of the message you are putting on the LCD. Okay, for that we need LED backlight. Okay, and that also has positive and negative, plus and negative. Plus will be connected to what? Plus will be connected to the, which one, plus 5 voltage. Then negative, this will be connected to the negative. This is the connection. Okay, and what about MQ2? So as I told you, is a gas sensor. It will detect what type of gases. Okay, this is used to detect it's a metal oxide semiconductor type gas sensor. Okay, detect gases like methane, butane, LPG, smoke, etc. So if you have some leakage in your home LPG connection, okay, this sensor will help you. Okay, smoke also, somebody is there, some room, some factory, there's a smoke happening. Okay, you want to detect that fire or smoke, we have this, we can use a sensor. Okay, it is an analog pin. Okay, so I told you it has 6 pins, 3 on the bottom, 3 on the top. 3 on the top will be connected to positive plus 5 voltage, or the plus pins in the breadboard. The remaining 3 on the ground. On the bottom one will be analog read pin to read the data from the sensor, converts the voltage into digital value from 0 to 1, 0 to 3. Okay, so whatever value we are getting in the analog is output, so it will be converted to digital, because we are calculating digital format. So that's why the date, whatever output we are getting in analog will be converted to digital. Okay, and the pin for that is, this is the analog pin. Input pin is connected to A0. The remaining 2 bottom pins are connected to negative ground, 1 via resistor. Other 3 are connected to positive pins in the breadboard. Okay, buzzer, you know, makes sound, alert sound, beep sound. LED for glowing the light. Okay, that's all the circuit. Okay, now let's see the code. What is the code, mister? So here I just added a header file, include a header file. Okay, liquid crystal.h for LCD operation. Okay, and I mentioned the pin numbers 5, 6, 8, 9, 10, 11. Okay, here whatever pins we are using. Okay, then we have to mention the pin numbers where LED is connected, buzzer connected, sensor connected, and that's the threshold value, like a one value we set for the base. Okay, we will compare the value of the gas sensor with this value. Okay, so red LED connected to second pin, S it is connected to pin number 2, green is connected to pin number 3. Yes, buzzer in 4, buzzer connected to 4th pin. Yes, gas connected to A0, as A0, threshold value is 400. It's a base value, comparison value. Okay, sorry. Setup, we have to declare the pins and its mode. What about the mode of each pin? So pin mode of red LED output, comma output means the mode of red LED, which is in pin number 2, is output. You know, the output devices, LED will always produce output. Okay, green LED also output pin. Buzzer is also output bit. That's why pin mode. In that is a feature. There's a special thing like pin mode. PIN small letter, M should be capital. Then mode. So second part of the command will have capital letter first beginning. Okay. Red LED come output. Pin mode, green LED output. Buzzer also output. Sensor. What is a sensor? Sensor is the gas sensor. This is an input device. Okay. So I'll put the device input. Then serial dot begin of 9600 means it's a baud rate. Okay, so that bandwidth, the speed issues. Okay, we declare that one. Then data transfer rate actually. LCD dot begin of 16,2. Mister, what is this LCD begin of 16,2? This is a command in LCD package. Okay, so what is that 16,2 means? We are setting the LCD display as 16 characters in one line can be printed, and we have 2 lines like that. Okay, that's what mentioned here. So here it's a liquid crystal displays 16 characters in a line per line, and we have two lines. Okay, so it begins with 16. See here, 16 rows. So 16th row, second column, or we call it as 16 characters, two lines. Okay, then we have loop. So here setup means whatever declaration you want to do, you can do only one time. Okay, loop means whatever values you want to read continuously, the statements which you want to read continuously, the operations, everything is in the loop function. Okay, loop method. So first thing, int, integer declaration, analog value. I put a variable name analog value. Here also I put a analog small capital V. Okay, this is actually not must, but still we put that variable name. Okay, equal to, this is must. Okay, analog read of, yani we are going to read the value of a sensor. Sensor is already connected to A0, yani gas sensor. We are going to read the value of this gas sensor, and we connected this into analog pin, so we can read the value as analog. Okay, so that's why I use analog read. In that analog read, R is capital of which sensor means which pin, A0, where I connected gas sensor. Now we are going to print this value on the screen. So here the monitor itself I will print serial.println or serial.print of analog value. Okay, value is printed. Then we are going to check if analog value greater than sensor threshold, yani whatever value you are getting in the output, no, is it greater than the threshold value 400? Then inside the if loop we have so many things. Okay, println gas is high. We want to print that message on the screen monitor that gas is high, and we have to turn on the red LED. So that's why digital write of red LED comma high. Mr. Why you put digital write? Because this is connected to digital pin, so it's a digital device. When you want to turn on the LED to make it high, to turn the LED on, glow it, we have to make it digital write, bracket the LED, the pin number comma high. If you want to turn off, make it low. Okay, so here whenever the gas and value is above a particular threshold value, the red LED should be high, and at the same time green LED should be low. And tone comma buzzer comma 1000 comma 10,000. What is Mr. tone of buzzer comma 1000 comma 10,000? Now I am going to set the tone for the buzzer. Now whenever the value of the gas sensor above threshold value, the buzzer should turn on, produce a sound. For that we use the function tone. Buzzer means where I connected, which pin number I put the buzzer. So pin number 4, comma 1000 comma 10,000. Yani what is that 1000 10,000? I already put here. This is the frequency of tone. What type of frequency you are going to play? Then duration, how long the tone should be played. Okay, that duration. Okay, so here, okay, sorry, not this one. That's what tone, they will produce a sound. Then clear the LCD screen. Then set cursor 0, 1. What is it, sir? Set cursor 0, 1 means top left position. Okay, so you can see here the positions of LCD. Set cursor 0, 0 means top left. So set cursor 15, 0 means top right. Set cursor 0, 1. This one is bottom left, not the top. Actually, bottom left. Okay, I want to print something in the bottom left. Okay, that's what the function. Okay, LCD set cursor. Then what I'm going to do after setting the cursor in top bottom left, right, we are going to print the value alert. Sorry. Okay, then delay 1000 means take a pause for 1000 millisecond. Okay, then clear the LCD, then set cursor 0, 1, same position, clear the messages. Then we have to put evacuate. So if something happens, no, first you have to put the alert message, then it will show evacuate. Everybody should be evacuated during that time. Okay, and delay during that gas is high. Else green LED will be high, red will be low. Buzzer, no tone buzzer means buzzer will not make any sound, Baba. Then clear the LCD screen, set cursor 0, 0, go to the top position, save message, delay for this much seconds, no action, nothing to happen. LCD, clear the LCD screen, set cursor 0, 1, there you have to mention all clear message. Okay, and delay again. This is the program. Now let's run the program. See what happens. Safe, all clear. Okay, the same coming here. Okay, now it's 396. Our threshold value is 400, right? Whenever it is above 400, it will make the, see the green LED is now on. Okay, whenever it is above 400, it will turn on the red LED and the message will be evacuate or what's the message, evacuate or alert. Okay, and the buzzer also will be turned on. Okay, now what I will do, I will go here. Okay, I will make this value 300 because I don't want to wait for the value to get 400. Okay, I'll just make it out 300. Now see, it has become 300. 396, gas is high. Alert, evacuate, gas is high is coming. Now see, the alarm is working. You want to see the gas value? See, it's like this. Gas. Okay, evacuate, alert, red LED is on. Hope you understood. Okay, I stop the simulation. Stop the recording.